In this video, we are going to do some algebra, but it will probably look a little different than what you were used to. So first we're going to start off with just a nice kind of warm-up question, and you might think like, why on earth are we doing, kind of like a basic algebra question in geometry? And you'll see after we finish with this. So if I had this as my algebra problem, and it said solve for x, I would think, maybe a good first step here would be to distribute the 3. So we got 6x minus 21 equals 8x plus 12 minus 3x. And then, this 8x and this minus 3x catch my eye. Maybe we should just go ahead and combine those like terms. So 8x minus 3x makes 5x plus 12. And then maybe as a next step, I don't know, maybe I'll subtract that 5x over to the other side. So I've got all my x's on the left. And then I need to add that 21 over to the 12. And I can finish to say that x equals 33. Right? So that wasn't too terribly difficult. Would you have done those same exact steps in the same order that I did them in? Maybe, maybe not. Does it matter if we do the same steps in the same order of an algebra problem? And no, you don't really have to. As long as, at the very, very end, we get to the same answer, what happens in the middle may be switched around a little bit. It may look slightly different, but as long as everything is done mathematically correct, then there are multiple ways you could solve this problem. So that leads us to what's going to be so different. If you had a really old school Algebra 1 teacher, they may have had you write this stuff out for every time that you did a line of your algebra problem. And so we're going to start using, and again, you're going to be like, why are we doing this? Why are we doing this? It's going to make much more sense once we really start talking about the geometry aspect of this. So for right now, this is going to be some like good algebra practice, but also tying in what we're going to get to eventually with geometry. So we have the 4, what I would call the main properties of equality that you would use in most algebra problems. So we've got the addition, PE, property of equality. So you may abbreviate property of equality with PE. Subtraction, property of equality. Multiplication, property of equality. Division, property of equality. We use some distributive property there at the very beginning of that last problem. And there were times when we combined like terms, and we're just going to call that step a simplify step. Okay, so whenever we do something algebraically in our problem, we're going to identify, for right now, which of these 6 things that we were really doing. Because these are the main 6 properties or things that we will use in solving algebra problems. Are they the only things we're going to use when solving geometry problems? Absolutely not. So let me just go through real quick and make sure everybody's okay with the 4 main properties. So this is just saying if A equals B, then we may add the same amount to both sides of the equation, right? We're allowed to add some amount C, maybe it's 2, I don't know. If I add 2 to the left side of an equation, then algebraically I have to add 2 to the right side of the equation. I have to maintain equality in my equations. All right? And so the same thing happens with subtraction. If I subtract something on the left side, I got to subtract the same amount on the right side to maintain algebraic equality. Same thing happens for multiplication. If I multiply something on the left side, I got to do it on the right side. And if I divide by something on the left side, I got to divide by something on the right side. Now notice this one has a little stipulation, right? C cannot be 0. Why not? Well, mathematically, we're not allowed to divide by 0. So you can divide by any number you want to other than 0. And then the distributive property, we multiply this outside term times the 2 terms on the inside separated by the addition or maybe subtraction sign. And then we have A times B plus A times C. And then again, simplifying when we combine like terms. I thought that said combine like terms when I originally did it. I think it did. Ooh, let me go back. Bum, 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 bum. Boom, yeah, it switched on me. Sorry. So when you combine like terms, or when you add like terms, or subtract like terms, when you combine them. All right, so now we're going to go back and we're going to redo this problem. But we're going to identify the properties that we really used along the way. So here was the very beginning problem. And I got to provide a reason for why I would know this beginning problem. And you might start scratching your head and wondering, well, which one of these reasons really is why we started with this problem? And none of them are going to match up. So I will tell you, when we do proofs or problems like this, the very first line, you had to be given this problem, right? I mean, this just kind of appeared out of thin air. So we're going to call this first step given. This was the given problem to you. Now, if you look at this second line, what happened to get from this first line to this second line? What did we do? And I can tell that something changed from here to here. And that's when we used the distributive property, right? So after you go from one line to the next, you identify the property that happened. So we use the distributive property there. Now, what happens in line 2 to be able to get to this in line 3? Well, let's see. It looks like the left side is staying the same, right? So nothing happened on the left side. But what about the right side? Now I notice there's this 5x, and before there was this 8x minus 3x. Well, this is when we combined like terms. And we said if we combine like terms, we're just going to call that a simplify step. Then what happens between steps 3 and 4? Well, let's see. I now see this x, and where did that come from? Well, that was from me subtracting this 5x over to this 6x. So I subtracted the same amount on both sides of my equation. And so if I subtract the same amount, then I use the subtraction property of equality. And then last but not least, what did we do? How do we get from this to this? Well, we got rid of that minus 21, right? And so we added the same amount to both sides. And so to finish this off, we have the addition property of equality. Now, one final thing in this problem, and you might be wondering, why is there that little box right there? Well, at the end of mathematical proofs, and you'll typically see this in like higher level, usually college math textbooks, which I have pretty much all of my old college math textbooks. But at the end of a proof like this, you'll commonly see this little box, and you don't have to put it, but to me it gives me satisfaction to draw a box. Basically what you would do is this here. Let me get rid of it. So when I'm done with a problem like this, I would draw a little square, a little box, and I would fill it in. And basically that's like putting the period at the end of a mathematical problem. Okay? So whenever you're looking in a college textbook, college math textbook, and you see like these crazy proofs that are being done, when you see that, you know that's the end of it. And the next thing that you see is still not the same problem. All right, let's try another one here. So you're going to notice that this problem has already been solved for us, but we're going to try to identify what properties happen to get from step to step to step to step. All right? So what did we say the first reason was going to be? I mean, where did this problem come from? Well, it was given to us. Now what happens to get from line 1 to line 2? What happened mathematically? And some of you might go, well, I would have distributed the 3/4 to the x plus 3. And you could have, but that's not what I did. So what happened here? I noticed the x plus 3 is still around. I noticed there's still this 3 here. But this 4 is no longer with us. And this 9 turned into a 36. So how do I get rid of a divided by 4 over here? And how do I make this 9 turn into a 36? Well, I would multiply both sides by 4. So what you typically won't see in these problems is the little steps that you would do like this. You won't necessarily see those, but you can still write them if you like. But really, this times 4 divided by 4 cancel, and then this 9 times 4 makes that 36. So I use the multiplication property of equality. Now what happens between line 2 and line 3? And again, you might go, well, I really want to use the distributive property. Well, you could, but I didn't. But what did I do? What did I use here? So if we notice now, that 3 is gone, but it wasn't because I distributed it. And if you notice, that 36 turns into a 12. So how would I get rid of this 3 that is technically being multiplied by this quantity x plus 3, and at the same time make this 36 into a 12? Well, I would divide both sides by 3 to make that happen. So I use the division property of equality. And then last but not least, I think we're all on the same step here. How do I get rid of this plus 3 to make this 12 turn into a 9? Well, I would subtract both sides by 3. So using the subtraction property of equality. Come on, subtraction. There you go. The subtraction property of equality. And then once we're done, we can draw that box, that square, fill it in, and be like, boom, we're done with that problem. So now I'm going to let you all try this one. So again, this problem has been solved in this particular order. So you have to follow how this problem was solved, and you have to identify the properties that are happening along the way. Remember, what is the first reason? How did you know that you were to start with this problem? Well, remember, because it was given to you. So now finish that one out. And then I'm going to give you a little more freedom with this last one. This last one, you may solve it any way you like. But as you solve it, you need to be writing the property that you're using every single line. Now, I just want to follow up with this one. You shouldn't do more than one thing for every line. What I mean by that is you should not, for instance, let me use this as an example, I would not in the next line do the distributive property and add this 4 over to the 8 at the same time, because now you're using two different properties in one move. So just do it one step at a time, one property at a time. So try those two out, and we'll discuss those, or I'll check them out, and we'll make sure you guys are on the right page.